Hi everyone, this is a question from topic 4 in class review. This is question number 6. You won't often see linear regression questions being a paper 1 question, but if it was in paper 1, it most likely just tests for your understanding of different components of bivariate statistics. In this question, it says a survey is conducted with 8 marathon runners. For each runner, X is the number of marathons the runner has completed, so that's the input. And Y is the runner's personal best time of the marathon distance. Let R be the correlation coefficient. The first question asks, write down the possible minimum and maximum values of R. And this first question has actually nothing to do with this particular case because the minimum and maximum values of the correlation coefficient are always going to be the same. The R value is going to be equal to or greater than -1 and less than or equal to +1. If you have a negative R value, so that's the correlation coefficient, it means that there is a negative correlation between your X and Y values. Whereas if it's positive, of course, it's a positive correlation. And generally, there is a strength level. So we're going to take the absolute value of R now and say if the absolute value of R is 0, of course, there's no correlation, whether it's positive or negative. If you have a value that's greater than 0, but it's still under 0.3, it's a pretty weak correlation, but it does exist. Okay, something greater or equal to 0.3, R less than or equal to 0.7. This will be like moderate correlation. Moderate. And if it's greater than 0.7, that's a stronger sign that, okay, we have a strong correlation. We can actually say that, yes, whatever the X value is does kind of indicate what the Y value is or what the output will be. And this leads us to part B. It asks, given that R is equal to -0.85, which of the following diagrams best represent the data? If we see here that it's negative, we know it should have a negative correlation. Now, if the correlation value or the R value was really, really low correlation coefficient, then we will have a scatter graph like this, okay? So somewhere between 0 to 0.3. 0.85, that's actually pretty strong, okay? We're going to be looking at something like this or something like this. So let's compare the two. If you look at D, we would say, yeah, there's still some variance. Let me pull out a ruler here so it's a little bit clear. If I were to draw a line of best fit, some of the dots would hit, but most of them are just a little bit off. Whereas if we were to draw a line along B, that's almost an exact fit there. So I would say B is very close to 1 for a correlation coefficient. That means in our case, -0.85 is most likely D. For the data in diagram C, which two of the following phrases describe the correlation between X and Y? Perfect, 0, linear, strong positive, strong negative, weak positive, and weak negative. Okay, in our case, we have a linear regression. So the first clear indicator for our answer for descriptors would be that it is linear. Is it perfect? No, of course not. Is it 0 relationship? No, there is a relationship. Is it strong positive? Absolutely. Okay, it's greater than 0.7 in absolute value, so it is a strong positive, which means it can't be a strong negative, weak positive, weak negative. So those are the two phrases that best describes the correlation.